Hey everyone, in this video we're going to be going over calculating pH and pOH for acids and bases. You will need a scientific calculator to follow along with the calculations in this video. Let's start by talking about pH. pH is something you begin talking about very early on in your science education career. And we think of it as this scale, right, that actually technically goes from 0 to 14 to describe how acidic or basic a substance is, right? From 0 to 7 on the scale indicates that something's acidic, and from 8 to 14 indicates that something's basic. And then, that magic number of 7 is where pure water sits on the scale, indicating that something is neutral. Okay, so we can see the examples on this, right? We have stomach acid and lemon juice and coffee as things that are acidic. You think of like soda or other things like that that are acidic to, like that, may not be good for your teeth or things like that, right? And then on the basic side, we have things that are cleaning products generally. Those are going to be more on the basic side. Well, pH is technically, is a way for us to indicate the level of H plus concentration in a solution, or the molarity of that acidic solution. So remember, we talked about that acid. So even if I have a generic acid here like HX, that's going to break apart in solution into H plus ions and then whatever my anion is, X there. So it's a measure of how many of those H plus ions there are. So this scale is logarithmic, which means that each number on the pH scale is changing by a factor of 10. So something that has a pH of exactly 6 is about 10 times more acidic than something that has a pH of 7. Okay. So that's pH. pOH is something very similar. It's like pH's sister. What it is, is it's very similar. However, because bases do not produce that H plus in solution, remember I could have, something that's a base that ends in hydroxide would give us our positive Y ion there. That's generic, right? And our OH ion. So bases don't produce H plus, they produce OH minus. So they can't use the pH scale with the same ease that acids can. And so there is actually a scale for bases that is the inverse of the pH scale. We don't hear about it very often because it's easy for us to just use the one scale, right? That allows us to actually make comparisons by just using the pH scale. However, the pH scale was not built for bases, it was built for acids. So we have to, now that we're going to be doing some calculations, understand that there is a second scale, the opposite sister of the pH scale, called the pOH. And we can see that it is literally the opposite. So 14 on the pH scale is 0 on the pOH scale, and then 14 on pOH is 0 on the pH scale. And then of course 7 is still that neutral point. That's kind of where it flips, right? So again, bases don't produce those H plus ions. pH is about H plus. So we have to have something called OH that allows us to quantify how basic something is, and it's called the pOH scale. Now again, acids can go right to the pH scale. Bases have to do a little extra work to get to the pH scale. They are not going to be able to get there as easily as acids. So all of these things are actually related. So we can have the pH, the pOH, the OH minus concentration, and the H plus concentration. There are ways for all of these values to be calculated for any solution. One thing we do need to remember is that anything in brackets, okay, means molarity. Molarity of that thing is when it's in brackets, okay? So let's see how these connect. Okay, we're going to start by looking at acids with the H plus and the pH. The connection between the H plus ions and the pH of something is that pH is equal to the negative log of the H plus concentration. Okay, so the negative log of the molarity of the acid, aka the molarity of the H plus, will give you the pH. If you've not really seen logs before, that's okay. All you need to do is find the value, or excuse me, the button on the calculation. If we want to go the other way, okay, if we want to go from pH to the H plus concentration, well, the H plus concentration is equal to 10 to the negative pH. So those are the two formulas that connect the concentration of an acid and the pH value. Okay? It's exactly the same for bases and pOH. So going between OH minus and pOH looks almost exactly the same. So to go from the OH minus concentration to the pOH is equal to the negative log of the base concentration. Same thing, right? And then again, we have that inverse of that formula to go the other way. So now I have the OH minus concentration, the molarity, equaling 10 to the negative pOH. Okay, so this is essentially, right, I'm almost divided with acids and bases, right? Acids dealing with the H plus and pH, bases dealing with pOH and OH minus concentration. However, remember pH is that scale that we like to use. So we need a connector between pH and pOH. And they actually do have a very simple equation that connects them that allows you to translate between them. And it is that pH plus pOH will always equal 14. Okay? That equation allows you to translate between pH and pOH. That equation is always true. It is very simple to deal with. Just quick addition or subtraction to help you find either the pH or the pOH. Okay, and there actually is a connection up here as well. This one is not as well-traveled. It's not as well-traveled of a road, but there is a connection up here. And it is that 1 times 10 to the negative 14th is equal to these two concentrations multiplied. Or, if I phrase that better, the H plus concentration times the OH minus concentration will always equal 1 times 10 to the negative 14th. Okay, so you would use that to translate between those two. So this is essentially your map, right? This is your pH and pOH calculation map. Anytime you're doing a pH or a pOH problem, you're going to need to figure out where you are on this map and where you're going. Okay, very similar to other maps that we've used in chemistry in the past. So once you figure out where you are and where you're going, you just use your formulas and the arrows to get there. Okay, so we're going to do two examples. Example 1. What is the pH of a 3.4 times 10 to the negative 5th molar HCl solution? All right, so before we can figure out where we are on the map, we need to figure out if we're dealing with an acid or a base. Okay, since this is HCl and it starts with H, it's an acid. So what that means is that our concentration of H plus is that concentration of the acid that's listed. Okay, because remember those brackets mean molarity. Since it's a concentration, we're looking at one of the things in the brackets, and since it's a concentration of an acid, it's going to give up that H+. If we think about what's going to happen when we have a solution of HCl, it's going to split apart into hydrogen ions and chlorine ions, okay, in a 1-to-1 ratio. So that's why we can say the concentration of H+ is the same concentration as the acid. So if I go back and look at my map, what I'm seeing is that I'm here, right? I am at the H+ concentration. The question asked me for the pH. So I just have that one road to travel from H+ to pH. The road tells me that the equation is pH is equal to the negative log of the H+ concentration. And so that's the formula I'm going to use. So I will rewrite that formula. And now I can just simply plug in my concentration, 3.4 times 10 to the negative fifth. Okay, pH is unitless. It just is a value. So all we have to do is find the log button, the negative log the negative log of 3.4 times 10 to the negative fifth. We plug that into our calculator and we get 4.47. Okay, I'm generally going to say give me 2 digits after the decimal for a pH value. All right, so that's my answer. So all I had to do was kind of think about what I was given, where I'm going, and follow the map. So my answer here is 4.47. Now I can also do a common sense check, right? Compare it to 7, right? If this is an acid, the pH should be less than 7, right? Well, 4.47 is less than 7, so that is our common sense check. All right, let's try one more slightly more complicated example. This example says the pH of a KOH solution is 10.75. What is the molarity of the solution? All right, so let's think about this for a moment. I'm given that the pH is equal to 10.75. I'm also given the substance. It is KOH. So my first step is always, is this an acid or a base? In this case, I have 2 indicators that we're dealing with a base. One, the formula, right? This is a base. 2, this pH is above 7, right? So I know I am dealing with a base. So what that means is when I want the molarity of that base, that means I'm going to be looking for the OH minus concentration because that is what's going to give me, this is the symbol for the molarity or the concentration of a base. So what I'm going to do, I'm going to look at what I'm given, where I'm going, and check out my map. So I'm given the pH and I'm going to the OH minus concentration. Let's check out the map. Here it is. Again, I'm given the pH, but I need to get to the OH minus concentration. So we are going to have to translate from pH to pOH and then from pOH to molarity. All of these formulas are on your reference sheet, and hopefully you copied this map down in your notes to be able to use on our example. So my first step is to translate to pOH, right? pH plus pOH is equal to 14. So we would plug in that value. pOH plus 10.75 is equal to 14. Subtract 10.75 from both sides. Right? And I find that the pOH is 3.25. All right. But I'm not done because I'm asked again for the molarity. So I need to now take this pOH and use it to find the concentration. The relationship that allows me to find the OH minus concentration is 10 to the negative pOH. So all I need to do is plug in 3.25. Now, when you have a number as an exponent that has decimals, that's not a whole number, you have to actually do this math. Always, okay? You should not leave concentrations like that. You should get numbers in scientific notation that look a little bit cleaner than having a value in the exponent that's not a whole number. So when I do type that in my calculator, 10 to the negative 3.25, I get 5.6 times 10 to the negative 11th molar. And that would be my final answer. So to recap with this one, since I was dealing with a base, I honestly had to do a little extra work, right? I had to translate from the pH, which is a common value to be given, to the pOH, and then use that pOH to solve for the OH minus concentration. So in a sense, like the pH scale was built with acids in mind, right? Or we assumed that acids are going to be able to go right to that pH scale. Bases are kind of lacking that privilege in a sense, right? They have to do some more work, and the system was not built. The system that's accepted was not the one that was built for bases. So make sure to use that map as you're working through these calculations.